Hi, welcome to Down East Audio. Over my years building and making, I've often needed a solid camera and imaging solution. I designed the open source piece of software, the Jevons Camera Viewer, to give me a way to experiment with different machine vision capabilities and filters, and to view two different camera feeds at the same time. So the main focus of this video is to get eye tracking working, but let's quickly go over some of the other great features. So there's dense optical flow, which compares the previous and current vision and shows the movement in different parts of the frame. There's also line and shape detection, which gives you the location within the frame of different shapes and the rotation of rectangles. You can also 3D print M12 lens holders, which unlocks a huge variety of different lenses. I have the 3D printed STL files available, open source as well, check the links. So you can mount the camera, giving you a more steady view, and you can use it as an overhead projector type thing. In this case, that's a 1.4 millimeter part. This is a LED here. We're just going to measure it using the grid function, which that's 0.1 millimeter gap in a pair of calibers, so you can use it as a measuring device. But none of this is going to be possible without a good camera system. So I'm going to show you a solid webcam that you can take apart and will enable all of the functionality you'll need. All right, so let's go through that. C270, you can buy it for 20 bucks. There it is. We're just going to take it apart real fast, pop the case off, and reveal some screws, pull the front cover off, and that'll reveal a manual focus lens. And just focusing the lens, you get pretty absurd macro capability, like actually out of this world, crazy levels. So just the stock lens gives you, I think, maybe 50 micrometers of resolution, which is definitely macro. So now we're going to take this thing out because you can use an M12 lens holder and unlock just insane potential with this lens. You'll see later we're getting down to like 10 micrometers and below, probably even less. 3 micrometers, it's insane. Anyway, so you have to remove the circuit board from the housing, just throw the housing away once you're done. You're never going to use it again. So there it is. It's absolutely tiny. It's literally just a Logitech like USB IC that takes the data from the image sensor and puts it on the USB bus. So we're pulling off those screws and we have removed the lens. All right, so you can 3D print these lens holders. I have all the files that I've designed on open source. You can see the link below. Please use them. They take like 6 minutes to print and they work great. You may have to adjust the percentage if you're using Cura to just make sure that the interference is perfect. So once you have the camera out of the enclosure and M12 lens ready, you can build the eye tracking apparatus. So the front facing camera is going to have some double-sided foam tape on the back to protect the user from heat buildup from the circuit board, and it's held on using a zip tie like so. The eye tracking camera is going to be mounted on the outside of the glasses, safety glasses like that, with one zip tie securing it to the glasses and another used to sort of control the angle and properly position it. And you'll secure the glasses to the user's head. That's me there. As you can see, the eye tracking camera, it's not really obscuring my vision that bad. So it could definitely be much worse, but it does work quite well. So now we're going to set this up. We've got the front-facing camera on the top camera viewport, and the bottom is going to be the eye camera, and it's focused quite close. We're going to turn the exposure down, and then using grayscale with a green isolating filter and edge detection and threshold, you'll just isolate that reflection of the LED off of the cornea and begin the eye tracking initialization. So I've set up a bounding box there. It's adjustable depending on how your apparatus gets constructed. I'm just looking around, making sure that that's going to work for me. It looks like it will, and it will. So we're going to proceed with initialization. For that, you're going to make the top picture box full screen and try and just align the monitor so that it's taking up the entire screen there. And it's a little weird. What you basically see there is a kind of feedback effect where the camera is viewing the the frame of the window, and then that's sort of being fed back through. So you're just going to look at the target. We're going really fast here, and press spacebar to advance. You just want to make sure that the target is really in the center of your field of view before you advance. And that's going to build a matrix of points there, you can see. And each one of those points corresponds to one of those calibration points. And we are also going to do some final calibration. I'm just looking at that dot, actually, in the green bounding box. And I'm making sure that, sort of out of my peripheral vision, that the gaze indicator on the top screen is lining up to that dot. So it's pretty close. It's never going to be perfect because you've got things like lens distortion, which really makes this difficult. It's a wide angle lens, 2.6 millimeter lens in an M12 holder, but it's good enough. So now we're in the this is a video I found of a helicopter flying low over the water, and I just found it kind of interesting how my gaze kind of tracks different things over the water. And these are some proximity flyers, wingsuit, and it's just a great example of how well the tracking really works. Here we're in a cockpit of a small plane, and he's coming in for on final here for that grass runway, and I'm just sort of doing what I would do. So I'm looking at my airspeed and my altitude there, and I'm looking at the runway and then the airspeed, altitude, runway, and you can't really see it, but he's at a pretty good speed. So the runway is right above stall now, and he's in the runway, airspeed there, runway, airspeed, and he's landed. So good landing, and yeah, you saw how that tracked pretty well there. So this is a good example of how eye tracking can be used to analyze a UI. In this case, it's hackaday.com or hackaday.io, and I'm just sort of interacting with this UI here. And I'm highlighting things just to sort of show you that I am actually looking there. So I'm bobbing my head a little bit. It's still tracking just fine. There's very little latency in this because there isn't that much calculation happening. So the Open Hardware Design Challenge, sort of scrolling down, and it's right on target there. So if you enjoyed this project, be sure to check out the code. It's all open source. I'll link to that in the description. And if you're interested in seeing more, please subscribe to this channel. There will be more videos for sure coming up shortly. Thanks for watching.